Chapter 5, Section 3 is on solving by elimination. We've learned how to solve by graphing and how to solve by substitution. Substitution is nice if you can get a variable by itself really cleanly, but that isn't always a possibility. The nice thing about elimination is it's a method that works every time. In its simplest form, what you can do is just take two equations and add them up. I'm going to add these up kind of in columns. Match up the x's, match up the y's, match up the numbers over there. I get 0x plus 11y equals 11. 0x is actually just 0, so I really get 11y equals 11. Divide both sides by 11, and y equals 1. I found that y equals 1. Now I take that value for y, plug it back into either of my equations. It doesn't matter which one. I'll pick the top one because the numbers are smaller for the x and the y's. 2x plus 3 times y equals 13, but I know that y is 1. So 2x plus 3 equals 13. So 2x equals 10, and x equals 5. My solution is the point 5, 1. I can check that. If I plug in 5 for x and 1 for y, I get 10 plus 3 is 13, and negative 10 plus 8 is negative 2, so those both check. Now that was the easiest type of problem where the x's just cancel immediately when you add them up. That won't always happen. Here in the second problem, I don't want to solve this one by substitution because none of these coefficients I can get by themselves without having a variable. So I'm going to use elimination. I have to think, what can I multiply one of the equations by to get variables to cancel? I noticed that if I multiply 3x by negative 2, that gets me a negative 6x here, and that can cancel with this positive 6x. So I'm going to multiply the top equation, the whole entire equation, the left and the right side, by negative 2. That gets me negative 6x minus 10y equals negative 34. And on the bottom, I still have 6x plus 4y equals 28. Now when I add these up, the x's cancel. These go away. I get negative 6y equals negative 6. And again, y equals 1. I take that y equals 1, plug it into any equation that I want. I can do any of the 4 equations I have, actually. It doesn't matter. In this case, I'll pick the bottom one. 6x plus 4y, and y is 1, is 28. So 6x plus 4 is 28. Subtract a 4 from both sides. 6x is 24. So x must be 4. It's the point 41. Now the challenge becomes figuring out what to multiply by to get things to cancel. You don't always have to cancel the x's. You don't always have to cancel the y's. Just do whatever looks possible. So like on this one, hopefully you can see, oh, if I multiply the top equation by 3, well, there's going to be a negative 9y, and there's a negative 9y. Now, negative 9 and negative 9 don't actually cancel. They have to be the opposite signs. So instead of multiplying the top equation by 3, I'll multiply the top equation by negative 3. That gets me negative 18x plus 9y equals negative 36. The bottom is still 5x minus 9y equals negative 3. I add these up and I get negative 13x equals negative 39. The y's have canceled. That's the whole point. If you don't end up canceling out a variable, you've done the elimination process wrong. Divide both sides by negative 13, and you'll get that x equals 3. If x equals 3, plug it in up here. Y is 2. It's the point 32. If I check that, 18 minus 6 is 12. The top checks. 15 minus 18 is negative 3. The bottom checks. Now this is the first problem we've had here, the one on the top right. The first problem where I can't just multiply one equation by something. 2 times something simple doesn't get me 3. Negative 3 times something simple doesn't get me 5. So instead, I'm going to multiply both equations by something. And here's the really handy little trick. This method will always, always work. I can just take this number and multiply the top equation by it. And I can take this number and multiply the bottom equation by it. So I'm going to do the top equation by 2 and the bottom equation by 3. Sometimes you have to switch the signs to get them to be the opposite. Right now I would get a positive 6 on top and a positive 6x on the bottom. So I can make one of them negative just to make them have opposite signs. And I'll pick a whole new color. And so I now have 6x plus 10y equals 14 on top. Negative 6x plus 9y equals negative 33 on the bottom, because remember that was a negative 3. I add these up and I have 19y equals negative 19, which means that y equals negative 1. If y equals negative 1, then I'll find x. I plugged it into this equation here. So I get 2x plus 3 equals 11. So 2x is 8, so x is 4. The solution to this system is the point for negative 1. 12 minus 5 is 7, and 8 plus 3 is 11, so it checks. So that little trick that I just showed, that can always, always, always work. Basically, whatever coefficient you have here, you can put on top. And whatever coefficient you have here, you can put on the bottom. So you end up always just multiplying CAX plus CBY equals CE. Yeah, you get the idea. I can multiply the top equation by C and the bottom equation by A, and I might have to switch the signs of one of them to make it work, to make them negative and positive, but that will make it so that I have on top here an ACX, and then bottom a negative ACX from this stuff, and those will always cancel. If you have a problem where things aren't arranged in a way that's very convenient, just rearrange them. I'm going to subtract this 3y from both sides and subtract this 5x from both sides. So I get 6x minus 3y equals negative 3, and I get negative 5x plus 2y equals 0, and then this I would solve by elimination. I'd multiply the top equation by 5, and the bottom equation by 6. That would give me my 30s and negative 30s that I want to cancel, and I would go from there. One last thing to mention, just like with substitution, if you ever get 0 equals 0, that means infinite solutions. It didn't happen in this examples, but it's very, very possible. And if you ever get something like 0 equals 3 or 1 equals 2 or something, that's no solutions. Just like we learned with substitution. Thank you. Hope you have a nice day.